Okay, we're here for lesson 17. We're going to go ahead and get started. Our other group member, Cheyenne, might join us later. She has been having some internet difficulties, so we will see. But we're going to go ahead and get started on our quiz. And for number 17. For lesson 17. So 1 true, 2 true. Number 3. What is the symbol for the true population proportion? Is it P squiggly line or P? I say P.
I'm going to say, what's the P squiggly line? I don't even remember that.
I don't know. I don't think we've learned that one yet because I don't remember that one.
Okay.
So for the next 2 questions, we will use N100 P.25 P hat 0.10. The requirements for constructing a confidence interval are satisfied, true or false. So this is the formula that we have to use. N1 minus P is greater than 10, or N times P is greater than 10.
Okay.
So if we type in all of those, 100 times 0.25, that's greater than 10.
Mm-hmm.
And then 101 minus 0.25 is also greater than 10. So true.
Wait, is that where we're timing it by 0.25 or the P hat point?
Well, this one is just using P. So
okay.
we would just use P. Sometimes you use P hat, like when they don't give you P, but since we have P, we just use the 0.25 since they already gave it to us. Okay, so that one's true. So number 5, the requirements for conducting the hypothesis test are satisfied. Yes, that's true as well. And then number 6, find the P hat. So that is X over N. And X was 0.25 divided by 100. Wait.
003.
Well,
is that what you guys got?
Is that right? Find the P hat. Oh, no, sorry.
Isn't that
next? No, yeah, you're sorry. The next 5 questions.
I was like, ooh.
New set of things. So the random sample of 60 people for the murder trial, and 45 of the defendants are found guilty. So sorry. So X is 45
divided by 60. Right?
Divided by 60 is 0.75.
All right, I got that too.
Okay. Create a confidence interval for the true proportion of first-degree murder trials. Input your answers for the margin of error, lower bound and upper bound. So I didn't, or I did, or I think I did. I did end up finding the margin of error for the 95% confidence interval, but not in the videos, only in the book. Cheyenne is watching her siblings today because her mom is in surgery. She completely spaced the meeting. Sorry about that. So that's what she just texted us. Okay. So let's see. Number 7. So the formula for margin of error that I have is M equals Z star times the square root of P1 minus P over N. So the standard deviation.
All of it over N or just the?
All of it. Well, just the square root part over N. So it's Z star, then the square root of P parentheses 1 minus P N parentheses over N.
Got it.
So that's a standard deviation. So we have to do that first. And let's see. We have all of that. So when we're using a 95% confidence interval, that's 1.96, I think, is the
95.
95%.
yeah.
Yeah.
So let's see if we can all get the same answer on this. So P, I'm putting my P is 0.75.
Your p hat. Yeah. Okay.
Divided by the sample was 60. And then square root of that equals that times 1.
I've got 0.014.
0.014. Not what I got. Let me.
Sorry, do you guys just do the square root of the P parentheses 1 minus P?
Yeah. No,
Well,
and the
And the N too?
Yeah.
Oh, okay, then
Right.
I did that wrong. All
the
right.
square root is over all of that division
okay.
problem.
Okay, then I gotta redo it real quick. Sorry. Sorry.
So Larky, for your margin of error, did you get 0.10956?
0.1095. Yes. So it changes
Okay.
it to 0.11. How did you get that, Marlies?
I got that
What do you mean
too.
how to
0.
Well, it's actually just 0.11.
Okay.
That's how we have to round it.
Not to 3?
Not to 3. Well, isn't there like a 0 or something afterwards?
0.110?
Yeah, if you don't have, you can put that 0 if you want, but it'll throw it off. It'll just take it off.
Okay.
So it just makes it 0.11.
Okay.
For the lower bound, I got 0.640.
Okay. Did you do that by hand or did you do that by the Excel sheet?
I did by hand. Is it wrong?
No, but I'd like to know how you got it because every time I try to do it in the Excel sheet, I get it. But when I try it by hand, I can't seem to get that. So I'm wondering if you can, maybe I'm doing calculations weird or something. The formula that you used for that, did you use p hat minus z star times the square root of p hat times 1 minus p hat over n?
So I just saved the margin of error in my memory on my calculator, and then I did the p hat minus my memory. So that was p hat is equal to 0.75, and then I just subtracted our margin of error, which was 0.11.
How come you subtracted your margin of error? Why did you think to do that?
What?
Why did you think to subtract your margin of error?
Because, so, you know, our formula says p hat plus or minus, plus and minus. So for the lower bound, you minus, for the upper bound, you add.
Right, so the formula
So
that you used for it, would it be p hat plus or minus z
Yeah, that's the one we have.
times
Z
times the standard
square root.
deviation or whatever formula?
Yeah, I think that's the same as the standard deviation formula.
Because every single time that I was doing it by hand, I get a different number.
Okay, what did you, never mind. I see.
So
So
you used, sorry, go ahead.
Oh, no. So you basically just did the 0.75, the p hat, subtract the 0.110 for the margin of error. And then you got 0.64.
That's for the lower bound. Yes.
Wait, Marlise, sorry.
What?
Is Z star the margin of error?
No, but this portion of your formula here, the portion that starts right after the plus or minus.
Yeah.
Let's see here. It starts right after the plus or minus. That starts right where the Z is. Okay. Right where that Z starts, that's your margin of error.
I see. Now, okay. But so wouldn't it, that does make sense that you would do that. That's very smart. But will you on a calculator, without your memory, type in that formula and tell me what you get? Sorry.
No, you're fine. I'm totally happy to do this. Tell me what you want me to start with, which value.
So I want you to do p hat, which is 0.75 minus or times, sorry, 1 minus 0.75. No, Holland, you already had a bottle. And then that divided by the sample, which is 60, right?
Wait, you know
Then we
what?
have that.
Sorry, Larky, wouldn't it be easier if you just did, are you trying to put that whole formula instead of just doing p hat subtract what we got for the margin of error?
Yeah, I am, because I just want to, I mean, you're right, it is easier, but I just want to see when I calculate it, if you are coming up with the same calculate, because every time I calculate this, I cannot get 0.64 for some reason.
Oh.
But do you ever do what Stacy said and just start with the
No.
1 minus 0.75?
I have not yet done that. Or wait, you mean just 0.75?
Yeah.
Well, I'll do it how you want me to do it, but this is how I do it. I start for like the order of operations. So I start inside the parentheses first, and I do 1 minus 0.75 times 0.75.
Okay. What do you get?
So I do the 1 minus p hat. I do the 1 minus p hat, and then that's 0.25, and then I multiply it by 0.75, and that equals 0.1875.
See, what the heck?
And then
You did 1 minus 0.75.
Yeah.
Then you did that times 0.75.
Well, first you can hit equals maybe. Just,
and then you got 0.1875, Marlise? Hey, hold on, baby. In this, you want Zija or in a Baba?
Yes, I got 0.1875.
Then did you divide that by 60?
Yes.
Okay.
Then I press my square root function key. And then I multiply that by a confidence interval.
By 1.96?
Uh-huh. That gave us our margin of error, which should say 0.1095, etc.
Okay.
At that point, I've saved it in my memory key.
Okay. So then how do you plus or minus p hat right to this next stage?
I clear my calculator because I have it in my memory.
Okay.
And then I put 0.75, which is our p hat. And then I minus my memory button equals 0.64.
Okay.
Because I subtracted the margin of error.
I must be not doing the order of operations right for some reason.
All I
So-
know is when I do break.
Holland. Marlies, did you
All right.
fall? Did you fall over?
My baby just put out the dog food. So
Oh, okay.
anyways, it's fine. It's fine. So all I know is that when I don't follow the order of operations, when I don't break the formula down and I just try to put the whole thing in like z times square root of p hat, that never works. I never get the right answer.
Normally I do like everything under the square root, then I square root it, then I do like p minus z, then I multiply it by whatever I got that was under the square root. So I must be doing it weird, but okay, sorry. So yeah, 0.64 for input for the lower bound. Did you try to type it into the thing at all?
Yeah, I put it in. So now I'm doing the upper bound. And I've got 0.8595, so that would round up to 0.86. Is that right for everyone else?
That's
Yeah.
what I got.
Okay, number 10. So if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? That was in our videos.
Yeah.
And it says
that
that it will decrease.
Mm-hmm.
And then this one, to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose that 1/2 or 1 divided by 2, whatever, is the smallest n can be. What are the both requirements? Well, so what number do we have to have in order to do that? So this is solving for n.
Can somebody show me this formula, like on their paper?
Yes. Marlies, do you have that? Mine's
Really?
pretty small. I don't think you'll be able to see mine. I don't know. Mine's so tiny. Right there.
You know what? I can, yeah, just hold it there for just a sec. Let's see. Okay, you know what? I do have this one written down. I guess I was just confused as when to use it.
So this one I had to ask the teacher about a while back on our last lesson. And so how this one works is, yeah, you do 1 divided by 2, which gives you 0.5. And so you know that your p is going to be 0.5. So if we do the n times p greater than 10, you just do to find it for n, you just do 10 divided by 0.5. That equals 20. So we'll say for that one, n equals 20. Then you have to do the same thing. You have to do 1 minus 0.5 equals 0.5, and then divide, like 10 divided by 0.5 equals 20. So luckily on that one, 20 is our answer. But sometimes when you use that other one, n1 minus p, because both have to be met. So if 20 works for one, but 40 works for the other, you can't say 20. You have to say the 40. Does that make sense?
Okay.
Do you know why?
Do I know why? Yeah, because
Yeah.
if you use 20 for the other one, like n1 minus p, you would get less than 10. Not in this specific question, but in some of them you get less than 10. And so you have to have greater or equal to 10.
Okay.
Does that make sense at all? Because I don't know if I explain it very well.
Well, I'm actually confused about the formula itself, because when you say the first part of the formula and you did 1 divided by 2 equals 0.5, and so then your n times p, which would be, But how do you know what n is if you're doing n times, or n, or sorry, n of, are you doing n times p or n divided by p?
Well, it's n times p is greater than 10. Or, well, you could just do equals to. You don't even have to do the greater than right now. If you write out n times p equals 10, but we know what p is. So if you did n times 0.25, is that what it was? 25 or 0.5? No, it was 0.5. If you do n times 0.5 equals 10, how do we solve for n? We divide by 0.5 on each side. And then n is left alone, so n equals 20. Because 10 divided by 0.5 equals 20. So now we have n.
Okay.
And that's for that formula. And for that formula, if you did do n times p, or if you did do 20 times 0.5, it will equal 10. So that one is good. So that one is distributed properly. Then you have to do the n parentheses 1 minus 0.5 equals 10. So 1 minus 0.5 equals what? 0.05 or something like that? Or 0.5?
Well, it would equal 0.5 because that would
Perfect.
equal a whole.
Okay. So then you just divide again to get n by itself. You have to divide 0.5 by 10 on each side. And that one also is 20. So luckily we can just put 20 as our answer. But sometimes I'm saying when you do the n 1 minus p,
Yeah.
it is not, those numbers are not equal.
So you always use the bigger one? Is that what you were
Not
saying?
always.
Okay, but most of
I'm not going to say always because I don't know if that's the exact fact, but normally that one brings up a bigger number and you have to have both of them satisfied. So you would have to say, okay, so I think it is, you kind of always use the bigger number if there is one, because they have to both be satisfied. Because now if you were to take, let's just say you did get 40 for that one and
Yeah.
you did 40, you'd have to have 40 on that one. You couldn't have 20, otherwise it would be less than. Does that make sense?
Yeah.
What I'm saying? Marlise,
Yeah.
does that make sense? Am I saying it properly? So let's see if this one, I hope this one's different. So suppose it's the same thing. So 1 divided by 10 to get it in easy form. So 0.1.
Mm-hmm.
And so you have your 10 divided by 0.1 to get it alone. That's 100. And then I think it's going to be the same, but.
That taking too long. Just call Matthew.
Or did you get 11.11111 for the second formula? Let me do that again.
Matthew.
I mean, like, I guess I don't understand how we know what n is.
You're solving for it, like x, like you're trying to find x.
Okay. Okay.
So these are different numbers. You probably should have gotten 11.11 for when you did the formula n 1 minus p is equal to 10.
10.10, is that what you got?
No, I got 11.11 basically.
Oh.
But regardless, so see, this is a different number.
Okay.
So if you put in 10, if you did, now if you use that number 10 and you do 10 times 0.1, just say it's 10. 10 times 0.1, you get 1. So that does not fulfill the requirement. So out of those two, we are picking the bigger number. That's the smallest one, because if we use one, if we now use 100 to fill in the end spots, that will make all of them always greater than or equal to 10.
So we're going to use the 100.
Yeah.
Okay.
So again, it is the bigger number. So that might be true that whichever the bigger number is the smallest for both requirements.
Okay.
I just don't want to confirm that because I don't know if we're 100% sure, but so far that's the pattern that I've seen.
Okay.
So number 12 is 100.
Okay.
Number 13. So the conditions for conducting a hypothesis test are satisfied. So we have to do this. So they give us P, so we just have to do P times the N. So yeah, that one's greater. And then yes, that one is greater. So true. Both of them are greater than 10, so it meets the requirement.
Okay.
14, what is P hat? So X over N, so 38 over 80. You get 0.475. And then this one is the formula again that you guys use, right?
Wait, the test statistic formula?
The Z, this
Oh.
Z equals, it's the compute the test statistic. It's Z equals P hat times the null hypothesis, which is the PO, right? Divided by the square root of PO. That's the one we're doing, right?
Z equals P hat minus P over the standard deviation, kind of.
I have that on the numerator is P hat times PO.
Oh yeah. Yep.
Okay.
Yeah. The null or whatever, the null
Yes,
hypothesis.
Yeah.
And so 0.60 is the null hypothesis.
Marlise, can you show me that formula real quick?
You want me to tell it to you or just show it to you?
Yeah, show it to me. Just want to make sure that. Oh, sorry. Oh, the square root. Okay. And that's the standard deviation on the bottom, right? Or no?
Yeah, pretty much. Minus the Z, I guess. But it's the same formula for the inside part.
Okay. All right, got it.
So did you do this one by hand, Marlene?
I haven't done it yet. I was going to.
Okay. So
Is this
let's,
something we can put into the Excel thing?
yeah,
Yeah.
you can put this into the Excel and it'll give you your Z score.
Okay, then that is what I should.
Super easy, actually.
Because yeah, that just looks really hard to do by hand.
We
Do we
could
just-
work it by hand, or if you have your Excel sheet pulled up,
Yeah, I'm just gonna pop it in and see if I get.
yeah, let me know what you get.
So the confidence level was still
0.95.
okay.
The null hypothesis, though, you need to put in 0.60.
Oh, instead of 0.6.
Oh, I get, well, doesn't matter.
Oh, okay. And then this is going to be greater than?
Yep.
No, less than.
I mean, yeah.
It was less than, yeah. Hmm.
So your Z score should be your answer.
Okay, so
What did you
negative
get?
2.282.
Yep. Negative 2.282 is correct.
choices.
So that's pretty easy to do it in
Well,
that.
I think I did that wrong then.
Did you do it by hand or did you put it into your Excel?
No, I did it by hand.
See, that's what I'm saying. Every time I do these things by hand, I feel like I get the wrong thing. I'm
Now
like,
I'm just mad and I want to figure it out.
me
0.6.
too. So I want to walk through. I want to try to do it with you.
This is what I'm doing. I'm gonna talk out loud.
Okay, and
One,
I'm gonna do it with you. Wait, let me pull my calculator up. I just exited out of it. Okay, you're doing 1
Right.
minus-
1 minus 0.6 times 0.6 equals 0.24
Okay,
divided by 80.
divided by 80.
Yeah,
Okay,
equals 0.003, and the square root of that equals 0.054. And I'm saving that square root in my memory.
okay.
And then I'm going to do the numerator, which is 0.475, right? Did I do that right?
The numerator point. Yeah, p hat 475.
Times,
No, minus.
it's minus? I
Yeah.
wrote that down wrong then. Okay, that will make a big difference then. All right, 0.475 minus 0.6 equals negative 0.374. Just a sec, sweetie.
Nice. I did get the right answer.
And then divide that by my memory. I got negative 6. Did you guys get that?
Nope. I got the right answer.
Yeah, I
Good
got
job.
that too.
Right. So Marlise, you did 0.475 minus 0.6, which equaled -1 or negative 0.125, right?
Yes. Yeah.
Okay. Then you did negative 0.125 divided by your memory.
I just had to re-punch it in. So what's the z-score? Did I get this right finally? Is it negative 2.282?
Yes. Yes.
So it only takes me 3 or 4 times, but then I get it.
Yeah, but that's so scary. I hate that.
Yeah.
That we have to check our calculations every time. Anyway.
I don't know why, but yeah, there we go. Okay.
I was having such a hard time with this the other day. I was like, I know that Excel is right. Why am I getting it wrong?
That's annoying.
So, okay, anyway, number 16, the p-value, it gives us that. We can just put that right in, 0.011.
Okay.
So since we know the p-value is less than the alpha, which gave us the 0.05, we are going to reject the null hypothesis.
Okay.
I have to read that every time.
Oh, I know. Me too.
So, which of the following summarizes the conclusion of the test? So there is sufficient evidence.
Yes.
So to conclude that, they wanted to know about the water decreasing. So there is sufficient evidence that the water quality in the area has decreased. So on mine, that's the last one.
Okay.
D.
Yeah.
The rescue bots are getting ready for their mission.
Rescue box. So, all right. So I'm so glad we went over those things, especially the by hand things. Thank you, Marlise. I don't know why that is sometimes so hard for me, but I'm going to stop the broadcast and we will see everyone next week.